Hey guys, Mr. T here, just doing a quick video on graphing logarithmic functions. So like all functions, logarithmic functions, you can graph them if you make the result of the function represent the y-coordinate for any given value of x in that function. All logarithmic functions share certain characteristics. So if we got f of x, the function of x is equal to log in the base a of x, then we can graph it if we make y equal log in the base a of x. Many of the characteristics depend on what the base a is. However, when a is 1, the graph is undefined, so you cannot graph a logarithmic function with a base of 1. So we're going to just go 2, 3 above. Now, what you'll notice with certain kinds of base is when a is above 1, it can't be 1, but if it's above 1, the function has a vertical asymptote at x is equal to 0, so it never touches the y-axis. The function is strictly increasing, so it's always going up and to the right. And as x increases, it goes to infinity, so it's always going up in that direction. As x gets closer to 0, though, it goes to negative infinity. So if you're going to the left, it's going down like this. So as you can see here, a logarithmic function with a base above 1 is going to look like this. So here you can see the red line is always going up, so always increasing towards infinity. You can see along the y-axis asymptote of y-axis, it never touches it. And then here, the bottom left arrow, you can see approaches negative infinity as you approach x equals 0. So those are some characteristics of a logarithmic function if the base is greater than 1. Now, you can't have it less than 0, you can't have it 1, but you can have it between 0 and 1. So if you have a base that's between 0 and 1, so a fraction basically, the function has a vertical asymptote at x is equal to 0, the y-axis again, so that doesn't change. But the function is strictly decreasing, so it always goes down as you go to the right. So that's the opposite. And as x increases, it goes to negative infinity. As x gets closer to 0, it goes to infinity. So it's sort of like it's been mirrored in the x-axis. So the logarithmic function before used to have this sort of shape, never touching the y-axis, going down as it gets really close to the y-axis, but then going up to the right as you get further in the larger x values. But here, when you have the base is between 0 and 1, you get approaching infinity as you get closer and closer to the y-axis, but it never touches it because it's an asymptote, but it's always going down to the right here. So you've got characteristics, but in the same characteristics, but in different situations. So vertical asymptote of y-axis here, always decreasing towards negative infinity this time. And then here approaches not negative infinity, positive infinity as x gets closer to 0. But it never will actually get to where x is equal to 0. It never touches the y-axis. So from these two examples, you actually notice some general features of a logarithmic function. That's regardless of their base. They're always on the positive x-axis side, so they're on the right of the y-axis. They never cross the y-axis onto the left side. They also always intersect the x-axis at 1. So you'll notice here that y is equal to log to the base of a half x across the x-axis at 1. And y is equal to log base 2 of x, also crossed the x-axis at 1. And lastly, in the form of m log base a of x, they will be the value of m, whatever this number is, when x is equal to the base. So at the point where the value of x is equal to the base, whatever number is in front of the log, that's the y coordinate. That's the y coordinate of the point. So we're going to illustrate that with an example. For our purposes, these properties are useful for locating some significant points in a graph of a logarithmic function. However, we'll also use a table of values to calculate more points because those aren't enough. If we have like 2 points in a graph, that's not enough to define a curve. So we're going to use a table of values to plot at least 5. Okay, so use a table of values for x up to 5 to graph the function y is equal to 3 log 2, 3 log in base 2 of x. So we've got a table set up here. I'll do it in blue, x and y. We'll go, well, there's no point doing x is equal to 0 because it can't be. So we're going to go 1, 2, 3, 4, and 5. So on your calculator, if you have a graphics calculator, Texas Instruments, you would press the math button. You would scroll down to a log base, and then that's what you're going to use to enter the base of 2 and then the x value of 1. And when you do that, you get, for 3 log in base 2 of x, when x is equal to 1, the y value is 0. Do the same thing, math. Scroll down to a log base. Make it log in base 2 of x, and you have to multiply it by 3 at the front. And then you'll get 3. Notice how when x is equivalent to the base, the value of y is going to be the number out the front. Keep going. So all I'm doing is plotting points using my calculator. They're not going to be exact, obviously, because we have to round. So the next one, when x is equal to 3, 3 times by log to the base of 2 when x is equal to 3 is 4.7549 to 4 decimal points. When x is equal to 4, that's convenient, it's 6. And when x is equal to 5, 3 times log base of 2 of 5 is 6.9658 to 4 decimal points. So now we can plot. So when x is equal to 1, y is equal to 0. When x is equal to 2, y is equal to 3. When x is equal to 3, y is equal to 4.75. So it's going to be 3.7549. So it's going to be 3/4 of the way between 4 and 5. When it's 4, y is equal to 6. And when x is equal to 5, y is equal to 6.9658. So really, really close to 7. Now we also want to plot and make sure that we show that it never touches the y-axis. It's a vertical asymptote there, so I'm just going to put a dot at the bottom there. And now I'm going to connect them with a smooth curve. Hopefully I don't fail at this too badly. There we go. So there's your logarithmic function drawn using a table of values and knowing or being aware of some of the features of logarithmic functions, basically, of both logarithmic functions with a base greater than 1 and also between 0 and 1. Alright, so hopefully that video is useful for you, and I'll see you in the next one.